Hello everyone. In this video you will learn about a classic method of connectivity-based clustering, namely hierarchical clustering. Together we will see how hierarchical clustering is implemented. After watching this video you will be able to implement the hierarchical clustering. So what is hierarchical clustering? It is a representative method in the family of connectivity-based clustering. It creates a hierarchy of clusters from data samples. In the plot on the right, we see A, B, C, D, and E, which represent 5 data samples in the feature space. Using hierarchical clustering, we can start with an agglomerative way, meaning that we first consider each data sample as one cluster. Then we calculate the distance of the clusters from each other and start to merge the closest clusters into new clusters. Next, we increase even further the distances and merge even more clusters into larger clusters. This is the agglomerative way to perform hierarchical clustering. We can also do it in a divisive way, that we start with the whole data set as one cluster and then divide the cluster into smaller clusters. Here let's follow the agglomerative approach. Now we can see in the plot on the right, the 5 samples are also 5 clusters with different colors at the beginning. We can find samples that are closer to each other, that are D and E. So first we merge D and E into a new cluster. Then the next closest ones are samples A and B. So we merge them into a new cluster. Let's continue on. We can find that C is closer to DE. So we merge CDE into a new cluster. Finally, we have one large cluster with all samples at the end of the agglomerative approach. In hierarchical clustering, the algorithm will have to decide to merge or split clusters. Therefore, a similarity measure must be used. So we need to define the distance or metric between data samples or between clusters. We also need a linkage method or criterion that determines the merging or a splitting of clusters in the process. There are various metrics and linkage methods available in the literature. We will need to use the appropriate ones based on the characteristics of the data. Typically, the Euclidean distance is used as the distance metric, and a method called Ward's method linkage criterion is usually used. It merges clusters that provide the minimum increase of the total within cluster variance. The result of hierarchical clustering are nested clusters. The clusters you see in the left figure can also be represented as a dendrogram on the right. It's a tree-like diagram. From the dendrogram, you can see the sequences that the hierarchical clustering apply for merging or for splitting the clusters. In the x-axis, we have the data samples A, B, C, D, and E. In the y-axis, we have the distance between those data samples. So when the samples are closer to each other, like D and E, they are the first one to get merged as shown in the dendrogram. Then we keep comparing the distances between samples and clusters, and in a moment we will merge A and B. In a similar manner, all samples are eventually merged into one cluster at the top of the dendrogram. Now let's see how hierarchical clustering can generate different dendrograms and clusters. Given a dataset with 10 samples, shown on the right, below you can find the dendrograms resulting from different linkage methods. These are dendrograms using the average method, the centroid method, and the complete method, respectively. We can see that the average method generates the same dendrogram as the complete method, while the centroid method generates different clusters for samples 3, 4, 5, and 6. Using the same dataset, here we can see how the selection of distance metric can influence the dendrogram of hierarchical clustering. 3 distance metrics, namely Euclidean distance, Mahalanobis distance, and the Chebyshev distance, leads to different dendrograms because the merging of clustering is based on the selected metric. When we have a dendrogram using a selected linkage method and a distance metric, hierarchical clustering determines the final clusters using a distance threshold. Using the same dendrogram, Here we show different clusters with the threshold 700, median of the dataset around 940 and 1300. We see the thresholds can be visualized by a dashed line cutting through the dendrogram, resulting in 3, 4, 3, and 2 clusters respectively. Here are some important comments about hierarchical clustering. It has some strengths compared with other clustering methods. That is, we don't need to determine the number of clusters before the analysis. The number will be given by the threshold that we later define. There are also some limitations though. First, it is that rather a procedure than the optimization of an objective function. This is because it depends on the distance between samples and the linkage method. Second, the linkage method is dependent on the characteristics of the data samples. This is a limitation because it's also shared, by other clustering methods that assume some kind of criteria. Finally, for hierarchical clustering, it could be very challenging to visualize when there is a huge dataset because the dendrogram is drawn by including all samples and linkage. But you can still obtain the clusters without visualizing the dendrogram. In this video, we learn how hierarchical clustering is implemented by using distance metric and a linkage method. It does not need to assume the number of clusters as an input, because the final clusters are determined by a distance threshold. And a dendrogram can be used to visualize the merging or splitting of clusters in hierarchical clustering.